Alright, hi everyone. Let's continue with our data structures and algorithm series. So far, we have looked at how to calculate time complexity and space complexity using big O notations. And today's video is going to be our last dedicated video for big O notations because now we are completely ready to calculate the performance of our algorithms. In the upcoming videos, we are going to see some of the common problem solving patterns that will help us in writing better performant code. Alright, in today's video, we are going to see big O values of objects and arrays. Objects are unordered key value pairs. As you can see here in the example, I have an object called user that has property age, name, and email and their values. Now let's see when we should use these objects in our code so that we can get the best performance out of it. We should use objects when you don't need order and when you need fast insertion, access, and removal operations. As the insertion, removal, and access, these operations has time complexity of O of 1. These are constant because we usually access data in our objects by their keys, right? If I want to access age in this object, I just need to pass age as the key and it will return the value, right? Which makes the time complexity of this operation as O of 1. Let's see some of these operations in our console. I already have the object here in my console. Now let's try to access name property in this object. For that, I just need to write user and then pass the property name, right? And directly it gives me the value. And for this, we don't need to iterate over these keys. We just need to pass the key and get the value, which makes the time complexity O of 1. Same for other operations like insertion. We just need to pass the key and the value to save it in our object, which makes the time complexity as O of 1. And let's see it in action. If I want to add a property called country in my object, I just need to type the user and my property name and then pass the value, right? Now you can see my object is being updated with the updated value and keys, right? Which makes the time complexity as O of 1 as there is no iteration needs to be done. Same for removal as well. To remove the property from this object, we just need to do delete user and then pass the property key, right? And now if we try to check our object, the key is removed, and for this no iteration was required. Just pass the key and you will get your output, right? Which makes the time complexity as O of 1. Now let's get back to the slides. We have seen insertion, removal, and accessing. Now it's time for searching. Searching has time complexity of O of n because if I want to search if this object has a value called vishal@gmail.com, I need to iterate over all of the keys and check their values one by one, which makes the time complexity of searching in objects as O of n. But if I want to access this email property directly, the accessing is O of 1 because I just need to pass the key and get the value, which is simple, right? Now let's check big O of some of the built-in methods of objects. We have object.keys that always returns the array of keys. It has big O of n. Why? Because it generates an array of keys, right? Which can be n number of length. Next one is object.values that also has big O of n. It returns the array of values where length of this array can be n. Next one is object.entries that always returns the array of arrays consisting keys and values that can also have n number of length. That's why it has time complexity of O of n. Last one is has on property, which basically tells us whether the property is present in object or not. It is similar to accessing the property in objects, that's why it has time complexity of O of 1. Alright, that's all about the objects. Now let's look at the arrays. An array is a type of list that maintains orders of its list items. For example, we are having two arrays here, array of numbers and array of alphabets. Each of these array items has an index attached to it that starts from 0. Now let's see when we should use these arrays. When you need an order, right, because it maintains the order on the basis of the indexes. When you need fast access to the elements based on the indexes, and when you have a use case where insertion and removal can be fast. Insertion and removal can be slow as well, but that depends on how you are inserting and removing the elements. Now let's look at the big O of arrays operations. Insertion depends on use case, because if you are inserting element at the end of this array, it will be fast. It will have time complexity of O of 1. But if you are inserting the array element at the mid or at the beginning, in that case this array will shift all of these elements by one index, which will increase the time complexity to O of n. Removal also depends on the use case, depends on where you are removing the array element. If you are removing it from the end, it will be fast with a time complexity of O of 1, but if you are removing it from the beginning, in that case all of the array elements will be shifted by one index, that will result into time complexity of O of n. Access can be fast here. Why? Because if you have the index, you can access it by passing the index only. Next one is searching, that has a time complexity of O of n, because if I want to search D in this array of alphabets, I need to check all of the elements one by one. This iteration will take time and will increase the time complexity, that makes it O of n. Alright, now let's look at some built-in methods of arrays. The first one is push method, that has time complexity of O of 1. As you can see in the example, we are having an array of 1, 2, 3, 4 and 5. But when we are trying to push 6 into it, it is not disturbing rest of the elements, just entering at the new index, right? Which makes the time complexity of O of 1. Similar with pop method, when we are trying to remove the last element from this array, it simply takes the last element away and doesn't disturb rest of the elements, which makes the time complexity O of 1. The next one is shift method. Shift method basically removes the first element from the array, which makes the time complexity as O of n, because if we remove 1 from this array, the element 2 will be shifted at index 0 and 3 will be shifted to the index 1 and 4 will be shifted to index 2 and so on, right? Which means removing first element from the array will require shifting of other elements, which makes the time complexity O of n, because we are doing a lot of operations to adjust the indexes of this array. Next one is unshift. Unshift basically adds one element at the starting of the array, right, which also have time complexity of O of n, because if I add a new element at the beginning, the rest of the elements will be shifted by one index. For like in this example, if you see, the first array was 2, 3, 4 and 5, but when we added 6 at the beginning, 2 was moved from index 0 to index 1, 3 was moved from index 1 to index 2 and so on, which increased number of operations and that overall time complexity. Next one is concatenation. In concat, we basically merge two different arrays to create a new one. For example, you can see we are having an array of 1, 2, 3, 4 and 5, and the second array that has elements 6, 7 and 8. And when we concat the first array with the second array, it gives us a new array, and the length of this array will increase as we are adding n number of items into our first array, which means it will require n number of operations. That makes the time complexity as O of n. Alright, that's all for this video. Now we have understand the big O of some of the operations that we have in objects and arrays. And now we know when to use object and when to use array. In the upcoming videos, we are going to learn some common problem solving patterns. Till then, take care and thanks for watching.